This semester, in Engineering 101, the Peaky Blinders design team was tasked with creating a device that can automatically adjust a set of Venetian blinds in response to various environmental criteria. As you can see in the photo, our design team has created a sleek device that hangs on the back of the blinds and allows the user to toggle them open or close with a set of buttons on the front. As you can also see in the photo, our device is well hidden and virtually unnoticeable at a glance. The device has been designed to respond to two variables in particular: heat sensed by a thermometer and light sensed by a photoresistor.
Over here we have the back side of the blinds, which are going to be facing the window, and this is where we have all of our wiring components, including our solar powered battery, our Arduino Nano, our PCB board, our temperature sensor, and the photoresistor. And these are all being hung up by a 3D printed housing compartment. Here we have the inside of the blinds, which include the metal rod, the aluminum shaft, and the stepper motor. The aluminum shaft connects the rod to the motor in order to adjust the tilt of the blinds in response to changing temperature and light intensity.
Here's the user interface as seen from the inside of the house. The blinds, of course, also have the function of adjusting the light level in the room for the user, so it is important for us to preserve the ability for the user to close or open the blinds. Our code is set up in such a way that allows the press of the button to override the readings of the temp sense and the light sensor. Our current prototype does not allow for this manual override to stay, as the sensors are constantly keeping the blinds locked in a certain position. Our ideal solution only allows the device to read the environment every half hour, which would make the manual override possible.
One of the requests of the client was for the device to save money on his energy bill and for it to be charged by batteries that can last for more than a couple of months. This was solved by using a solar powered battery that is both energy efficient and environmentally friendly. The battery will face the side of the window and provide power to twist the blinds.
We elected to use a PCB board in our final design for two equally important reasons. The first was to make the device more discreet, per our client's request, by drastically decreasing the amount of wires. The second was that we were very constrained for space, as we were not allowed to stick compartments onto the client's wall. And as you can see here, the PCB board is extremely compact as compared to the proto board, which would have had lots of wires.
The temperature sensor, as shown above, is inside an acrylic box so that it is able to measure a certain volume of air, which accurately senses temperature differences within that volume of air. Moreover, the gray box has a hole in it because of difficulties in the initial prototyping phase.
Finally, this is a complete wiring component in the back side of the blinds that includes a code for both the temperature sensor and the photoresistor. Inside the gray box is an Arduino Nano and the PCB board, and there is also the solar powered battery right below it.
So initially, I click the button to open the blinds using the manual override. Once the blinds are open, to test the closing manual override, I click the close button. As you can see, the blinds follow the command and close it. Be sure to hold the button for roughly 2 seconds because the buttons are not all that sensitive in order to avoid accidental opening and closing. Then, as the blinds are closed, I cover the photo sensor in order to mimic a dark environment in which the blinds open, as shown in the video. After this, I use the flashlight on my phone to mimic a bright environment, and the blinds close in order to finish the testing cycle. During these experiments, the temperature remains constant.